Do you notice that the winter in recent years come later and later? It is because too many greenhouse gases have been trapped in the atmosphere, and we call it global warming. With the increase in temperature, people are more dependent on the air conditioning to maintain body cool and dry. However, it may be a vicious cycle, since open air conditioner will release more greenhouse gases which accelerating global warming, and people will more rely on the air conditioners. To alleviate this problem, personal cooling fabric, nanoporous polyethylene is invented. This fabric can make you feel cool and dry while sweating, and thus lower the dependence on air conditioning and emission of greenhouse gases. According to Feldman's experiment in 2016, the nanoporous polyethylene is 4 degrees cooler than cotton when placed down on bare skin on the same temperature. However, why does fabric have such properties? It is mainly because of the heat transfer mechanisms, namely conduction, convection, radiation, and evaporation. The diameter of pores of nanoporous polyethylene is ranged from 50 to 1000 nanometers, which is transparent to infrared radiation but opaque to visible light. It means that the fabric allows the radiating escape from a person's body but do not absorb the heat from sunlight. Around 50% of the heat is lost via infrared radiation from human bodies under normal conditions. However, the normal textiles, they block the passage of heat emitted by body skin and therefore keeping body warm. This kind of thermal insulation is ideal in winter, but it may be a disaster in summer, especially in Hong Kong, where it has a very high humidity and temperature. On the other hand, nanoporous polyethylene fabric can make humans feel dry and cool. It is because they are highly transparent to infrared radiation, and the spectral structure of the fabric is capable to scatter the sunlight, so heat would not be trapped. Actually, conduction exists in all textile fibers. Most of them transfer heat of sunlight to fabric, except some metallic fibers. It means that the conduction may increase the skin temperature as well as the fabric itself and the sun. However, due to the high radiation of nanoporous polyethylene, it will offset the conduction when sunlight strikes on the fabric. It means that radiation will be carried out when conduction still occurs. Thus, the cooling effect occurs as frequent as the conduction in hot temperature. When temperature of the external environment is higher than the skin temperature, heat loss through evaporation or precipitation, and it perhaps is the main method of heat loss. For other textiles, the vapor may condense on the interface and make the skin feel cling as the passage through the textile may be blocked, or the transmission rate is slower than generating extra moisture vapor. However, Feldman stated that the nanoporous polyethylene fabric is permeable to precipitation vapor and air, but still waterproof, because the water droplet is much larger than the moisture vapor, so it will be blocked by the textile. Therefore, the sweating wearers would not feel cling when they wear this kind of fabrics, as most of the moisture has been carried out through the small pores. Breathability can be achieved by evaporation as well as convection. It is because breathable fabric can transmit moisture vapor by diffusion or convection and therefore facilitate evaporative cooling. The movement of fluids play a dominant role of transferring heat in liquid and gases and fasten the evaporation. Also, nanoporous polyethylene fabric has some tiny holes on the surface and carry out the capillary action, so make the fabric breathable and dry. Capillary action is the ability of liquid to flow in narrow spaces without the assistance of external forces. As the narrow channels, as the more effective wrinkling effect, as well as quicker evaporation and spreading of the precipitation. It implies that when more narrow channels and moisture presence, the cooling effect would be more effective. However, the cooling effect is associated with the sweat, so fabric is normally designed for outer wear instead of formal wear.